Let's introduce some notation for triangles in general. The angles of a triangle will be denoted with a capital A, capital B, and capital C. The sides opposite to the respective angle will be denoted lowercase a, lowercase b, and lowercase c. And a triangle will be either denoted by the sides or the angle. For example, this triangle will either be called capital A, capital B, capital C, or lowercase a, lowercase b, lowercase c. Using trig functions so far, we've been able to solve right triangles. In the next two lectures, we will introduce theorems called the law of sine and the law of cosine that will allow us to solve more general triangles, triangles without right angles. In general, a triangle is determined by three pieces of information out of three sides and three angles, where we have that at least one piece of information is a side. We'll be looking at the specifics of each case in a little bit, but let's first state and derive the law of sine. The law of sine states that in any triangle, the lengths of the sides are proportional to the sines of the corresponding opposite angles. In a triangle ABC, symbolically we write it as follows. The sine of angle A divided by side A is going to be equal to the sine of angle B divided by side B. And this is going to be equal to the sine of angle C divided by side C. Let's derive the law of sines now. The area of a triangle is always given by 1/2 base times height. We can obtain the height by forming a right triangle by subdividing the angle C as follows. The height in this case is then going to be equal to B times sine A. Then the area is going to be equal to C times B times sine A. All this multiplied by 1/2. We can play the same game. Again, another way that we can find area is by subdividing the angle A. In this case, our height is going to be equal to C times sine B. Then we could write our area formula as 1/2 times A times our C sine B. Playing this one more time, we could subdivide our angle B. In this case, we would have a height equal to A times sine C. In this case, our area formula would be 1/2 C, that should be a B, of our A sine of C. Now, take the different representations that we got for our area and set them equal to each other. Multiply this entire equation by 2 and then divide by ABC. And we obtain our result. Sine A divided by A is equal to sine B divided by B, which is equal to sine C divided by C. And let me reiterate that the numbers on the bottom correspond to sides of our triangle, and the capital letters correspond to the angles. Let's go ahead and apply the law of sines to solve a triangle. Here we're given a triangle with two angles and one side. Let's label this triangle a little further. We'll call this angle A, this will be our angle B, and this will be our angle C. This makes this side B, this is side C, and this is side A. Since we know that the angles of a triangle have to add up to 180 degrees, then we see that this has to be 50 degrees. Which means to solve this triangle, we need to find side A and side C. To do this, we're going to use the law of sines. We know that sine of 100 degrees divided by side C is going to be equal to sine of side B divided by side B. Well, we found what the angle B is equal to. This is going to be sine of 50 degrees divided by 2. And so we have a formula where we just need to solve for C now. Since sine of 100 degrees divided by C is equal to sine of 50 degrees divided by 2. Dividing both sides by sine of 100 degrees, we get 1 divided by C is equal to sine of 50 degrees divided by sine of 100 times 2. Or another way to write this is that c is going to be equal to sine of 100 degrees times 2 divided by sine of 50. And this is approximately 0.9848 times 2 divided by 0.76604, which is approximately equal to 2.571. So side C is just about equal to 2.571. Now we just need to go ahead and find A, and we'll be repeating the process more or less. Again, law of sine tells us sine of angle A divided by A is going to be equal to sine of B divided by B. Plugging in what we know, sine of A is going to be equal to sine evaluated at 30 degrees divided by A, which is going to be equal to sine of B, which is sine of 50 degrees divided by 2. Again, we just need to solve for A here. And this is going to give us that A is equal to sine of 30 degrees divided by sine of 50 degrees times 2. And this is going to be about equal to 1/2 times 2 divided by 0.76604, which is about equal to 1.305. And we're done. We found all the sides and all the angles of our triangle.